Hi, so today we're going to be discussing a no backlight issue. This is brought to me by a friend who is being driven nuts by it. It's an 820-2523 board for an A1286 from 2009, aka an old piece of shit. I usually prefer avoiding working on these, but for a friend I will always help. So let's take a look here and see what's going on. So when I shrink this so you can see what's going on my microscope camera, you will see some nasty, nasty bullshit. So to give you an idea of what's going on here, let's get a pair of tweezers. Okay, my desk is disgusting, so I can't find a set of tweezers. It's about time for me to go home. I'm tired and dead tired. Alright, so over here you're going to see a wire, and this wire is going from my power supply. And it's going to a pin on the LP8543, and that's a ground wire. So I have this power supply here that I use for testing purposes. I can use it for finding shorts, and I can also use it to provide power to where I think power should be if there's no power. Now, one of the things that went wrong on this, let me just go over to the screen capture. I love this software. I love Open Broadcaster software. Like, somebody made a comment recently on my channel about how, yeah, finally open source software that actually works. And yes, this does work. I know it's fucking surprising because it's open source software for multimedia purposes. You wouldn't expect it to work, but it does, and it's cross-platform and it's free. I mean, I donated these people $100. If you need something, anything remotely like this, try it out and please donate to them. Please show that people are actually willing to pay for open source software that doesn't suck. Because there is a severe lack of it when it comes to any type of, video editing, video recording, production kind of stuff like that. So anyway, so here's what was going on. I've talked about the backlight circuit in enough other videos that I don't feel like I have to go into how this thing works here. Long story short, this is a DC boost circuit. So you have input here, which is 12.6 volts. You have a backlight controller over here. This is an inductor, also known as a coil, also known as the thing that never goes bad. So if you read on a forum and you have no backlight, you need to replace the coil. No, you need to hit X because that forum is filled with fucking idiots. Over here you have a diode, and over here you have output of backlight. Now, to give you a very, very quick and dirty and nasty introduction to how a DC boost circuit works, this is an inductor. The power that goes through an inductor is going to go through it in a funny way compared to how it would just go through a straight wire. Now, this over here is actually going to take this 12 volts that's coming along here. It's actually going to short it to ground in intervals. Now, what that's going to do is that's going to cause the power that's going through here to zoom through here as fast as possible. But then it's going to stop because right over here where this chip is shorting it to ground is going to go away. So you're going to have power coming in, going and stop, going in, stop, in, stop. And this constant starting and stopping short with the inductor behind it is going to cause voltage to build up in the inductor. So you're not going to have 12 volts. You're going to have 12 volts, 16 volts, 18 volts, 20 volts, 30 volts, 40 volts, and that is going to get sent out this way. So it goes through this diode. These capacitors smooth it out, so instead of looking like a bunch of pulses of shit, it just looks like a straight line, and that's what allows you to start out with 12 volts and actually get out to 40 or 50. Obviously, you're not going to have the same current capability that you would if you were just sending 12 volts because you're boosting the voltage at the same starting voltage without adding anything. So, but this is a screen. You don't need a lot of power to power a screen. It's an LED backlit screen for a laptop. So what happened here is this diode was open. So a diode is supposed to pass electricity in one direction but have resistance to it in another direction. This diode was open, which means that 20, 30, 40, 50 volts for the screen over here was actually going backwards. And so what I thought is, so this is a 12 volt circuit over here. So everything going backwards over here, once this diode blew for a split second, there was up to 50 volts that went back this way and probably sodomized everything. I replaced LED driver, no luck. I looked in the area, after the diode was blown, caps were good. Again, the coil, keep in mind, the coil will never die. Repeat with me, the coil will never die. It's not the fucking inductor. If you just look at what this shit looks like, you'll understand what I mean. Let me just bring it up on the microscope just so you can get a better appreciation of why this thing will never die and why all these people on internet forums that tell you that the coil is what is bad are just complete fucking idiot, ignorant, dumbass bullshit. So let's find it over here. And alright, so the coil is the inductor. So okay, you see this? You see this? This is not good. You're not going to break this. Actually, you can't see it because it's outside my viewable range. Okay. Alright, see that? That's it. You're never going to break this. This is huge. This is a huge coil that is... No, you're not breaking that. So people who say that that's what blows, again, they're idiots. Don't listen to them. They're dumb. Okay, back here. So you have this. Now I went backwards and backwards and backwards until I got over here. This is the next step. See this? So this says critical and its voltage into the LP8543. I'm not sure what this is supposed to be. So since I'm not sure what this is supposed to be, as you can see on pin 23, I don't know what that's supposed to be, I decided that I would use my brain. So the way that I decided to use my brain is I decided to Google this LP8543 number over here. When I Google it, I get a data sheet. Now when I look at the data sheet, you're going to get to something called pin descriptions, which is going to tell you what every pin actually does. So it says on pin 23, input power supply 5.5 to 22 volts. See, pin 23, V in, input power supply 5.5 to 23 volts. So it gives me an idea. Now over here, when I follow this V in up this way, we go up here, it shows me that it has power that comes through these transistors. So remember, drain to source, source to drain over here. This is pretty much like, it's either open or it's closed. Think of it like a wire. So when everything's working right with the system, when it's receiving the voltage it's supposed to, this goes through here, this goes through here. So the way this works is this is PP5VSO. This is 5 volts from the computer's one of the main power rails. And it says 5.5 to 22 is acceptable. Let's just assume that 5 volts is good enough. Now, it's going through here. It's going through here. You know, remember how a transistor works. Drain to source is just like a resistor that turns into a wire eventually, depending on what's at the gate. You're going through here. Then it goes through here. And then it goes through here. So... and now this power is going to get sent to ground depending on whether backlight enable here is doing. So the whole idea here is this is 5 volt input for the chip. This is a 5 volt power rail that the chip needs to actually function. It needs that, you have 12.6 volts here. That's not power for the chip. This ppbus underscore SO underscore LCD backlit underscore power is not what actually powers the chip. What powers the chip is this 5 volt input. This 12.6 volts over here, that's power that the chip is going to transform into 50, but that's not what actually powers the chip and allows it to do what it's doing. That's just the power rail that the chip will then be controlling once it turns on. V in is the power that the chip actually needs in order to turn on and get to work. And that is only going to show up when this backlight enable signal is over here, or else that 5 volt power supply for the chip is going to get shorted to ground. Now, when I measured over here, I noticed that there wasn't 5 volts over there. And these resistors were measuring the way they were supposed to be. And these transistors were measuring the way that they were supposed to be. So, what do? Well, what you do is you try to put 5 volts on that rail and see if it fixes the problem. And that's what you could see on the microscope. So in the microscope, what you're going to be able to see is that on 5 volts, I have a piece of Cat5 wire, which is why I'm very, very careful about what I'm doing on my desk, because I know if I touch that thing the wrong way, it is going to rip that pad off of the board completely, and it's just going to be a miserable, miserable nightmare. So as you can see there, I have that piece of Cat5 wire. I had to trim it a little bit, so you have literally one strand of it going from my HP Agilent 6542A power supply to there, so that I can send 5 volts. And if you want to see if that fixes my problem, you could see what happens when I decide to turn on my power supply. So my power supply here is set to 5 volts. So when I turn my power supply on, when I hit the button, what happens? But a light. I get a light and a flashing question mark, which means that I fixed my problem. Now, this is going to require a little bit of arts and crafts, which I hate, so my friend is going to be doing that himself. Because what happened here is those resistors are actually on the other side of the board. So I'm just going to remove this. I'm going to unplug what I'm doing so that I could show you a little bit of what I mean. And once I unplug this, again, he's going to be on his own. Such is life. So I'm going to show you what I mean in the microscope. Let me shrink myself, since you don't need to see me anymore. All right. I'm also going to show you what some of the hints look like. All right. I didn't have the air filter on. There's a lot of flux there. I'll have to clean that. So see, that is the pin right there. See that? That is the pin that I pointed to with the soldering iron. Now see how it goes to that? See how that doesn't really look very nice anymore? Yeah, it doesn't look very nice. Now when you see something like that, that actually goes through the other side of the board. Those, when you see something coming from a trace, from a pad, and it's going to a circle and there's a hole in the middle, that's actually going to be going to something on the other side of the board. So what I want to do here is I want to show you what the other side of the board looks like. I'm going to show you where those little resistors are. So what I showed you there was that there were some resistors in that circuit, just in case you forget what they look like. Let me just show it to you again. on the screen capturing tool. So right over here, you see you have R9701, you have R9735, you have R9702. So those are all going to be in this area that I'm about to show you. Alright. Yeah, so it's over here, and you can guess where the voltage that is messed up is supposed to be. Like, hint. See this? This goes to the other side of the board. So what my friend is going to have to do is, when he has the time to come here, he's going to have to make a hole in the board in that area, and then he's going to have to run a wire. Because the trace from one side of the board to the other side of the board is actually blown. These are points that are very, very easy to break because they're very, very small, very, very thin. So he's going to do, what he's most likely going to do is he's going to take a piece of battery wire like this, which is pretty good. It's good stuff for this. So this is an A1278 battery connector that's broken. He's going to take a little wire like this. He's going to make a little hole in the board using something that he can use to poke through the whole thing, like this, and he's going to poke the wire through. And he's going to solder it on both ends to where it's supposed to go, and that's going to fix the problem. You know, again, not all backlight issues are simple. A lot of people, like, again, this is one of the reasons that I don't no longer have a no backlight coupon. So I used to have a no backlight coupon, meaning if your only issue was no backlight, you would get the service for cheaper. Not even just the fact that nobody who used the no backlight coupon actually had no backlight. Your issue was your computer was totally dead, and that's why you had no backlight. But also, sometimes they're a pain in the ass. Again, he's not dumb. He has experience with this. Not to mention he was trained by the best. Not going to say who. But the point is, sometimes you have these issues that are just a pain in the ass, and it's not as simple as you think it's going to be. Just because it's a no backlight doesn't mean it's going to be easy. So again, just to go over it again on the screen capturing tool. Let me shrink this so you can see the screen capturing tool. This is a DC to DC boost circuit. You start out with 12.6 volts over here, and it's going to go through an inductor. Now, what you're going to do is right after the inductor, you're going to short it to ground, but you're going to short it to ground with the changing frequency. So it's going to go to the ground and stop, go to ground and stop, go to ground and stop. And that's going to create pulsing. So the voltage is going to get ripped through this inductor, which it doesn't like. You can read about that if you read up or go to college and learn about how DC to DC boost circuits work. I'm not going to explain it the scientific way here. I don't have the vocabulary to, nor do I care to make things more difficult for you to no reason. But think of it like stopping short in a car. Like for that one moment that you're going like this, you're going really, really fast. And think about stopping short over and over again. Think about the energy that happens every time you do that. And that's what you're doing here. So this chip is shorting that 12.6 volts to ground, but very, very quickly then stopping. Very, very quickly then stopping. Through a coil, which is a pain in the ass to get the power through. And what happens is you wind up getting that voltage built up in the coil. So you have 12, instead of it just being 12 volts, you have 12 volts, then 12 volts, then 12 volts. You wind up at something like 36 volts. And again, you don't have the same amperage that you would have if it was just a straight 36 volts, but the voltage itself is actually higher. And then you put that through a diode, and that winds up going out, so that you don't have all that power going back through here and causing a clusterfuck. Now, this diode itself was open, which wound up blowing things that came before it. So the LP8543 didn't look any good. Definitely not on this section, and mainly this voltage in the point directly right behind it was burned to shit. We fixed that, and it works. You saw that when I hit the on button on my power supply that it all worked. Hopefully you learned something today. Hopefully you learned something about how a DC to DC boost circuit works when you actually want to not just take voltage and bring it down. I've talked about that in other videos, how you take a higher voltage like 5 volts or 8 volts or 12 volts and turn it into 1 volt for CPU V-core. This is how you do the opposite. This is how you take 12 volts from the machine's main rail and turn that into 36, 39, or 50 volts required to power the backlight on the screen without any other power supplies. Hopefully you learned a little bit about the backlight circuit. Hopefully you learned a little bit of basic electronics. Again, DC boost circuit, ignore all the, again, you're going to read pages upon pages of electronics theory and you're just going to want to kill yourself. It's very simple. You get all this entire page of stuff. A chip is there to stop the car short over and over again. And it's those little stops and stops and starts and stops and starts and getting slammed through that takes the 12 volts and brings it up to 36 to 39. I know a lot of people who are good with electronics. I know a lot of electronics professors, a lot of hardcore electronics, die-hard, do-it-yourself people are going to hate me because I'm explaining it in the way that I am. But the point here is not to explain it where you understand the formulas and you understand all the nonsense behind it. All I want you to do is is understand in your head a basic idea of how that works without having to get a master's degree in college, without having to sit through a 6-month course, without having to know what the little symbols and the theories mean. I want you to be able to look at this and innately understand what's going on in your brain with the knowledge that you already have. And if you can do that, I've done my job.